Now we come to horizontal asymptote. So this is a little bit different, and I wouldn't say trickier, but just there's a thought to go through in figuring out what you have for horizontal asymptote. So there's three cases. Our first case is if the degree of the denominator is more than the degree of the numerator. So like it's in the case that we see right here, it's square down below and it's linear on top. That's square, that's linear. So in this case, think about what happens as x gets really big. So we're talking about more like in behavior type stuff. As x gets big, the numerator grows slower than the denominator. So when like x is 10, we're going to have in this case 40, 42, whatever, over 140, 135. Or if x is 100, you see it's going to be like in the 400s over the, what is 100 squared? 10,000. So we just see it's growing much faster down below than on top. And so as x gets bigger and bigger, that becomes smaller and smaller. So in that case, you have a horizontal asymptote at y equals 0 at the x-axis. In the second case, if the degree of the denominator is less than the degree of the numerator, so like we have here, we have a squared on top and a linear on bottom, so that's a degree difference of 1. So just think about that. If you're a degree of 1, then that's a line, equation of a line. We get a slant asymptote or oblique asymptote, some books call it. And this is an example of that. And you basically divide the numerator by the denominator, and what's left over is the equation for your slant asymptote. And you ignore the remainder in that process. In the third case, if the degree of the denominator is equal to the degree of the numerator, there's a horizontal asymptote at y equals a sub n over b sub n. That's the coefficient, the leading coefficient on top over the leading coefficient down below. I notice the ends are the same because these mean you have the same degree on top and bottom. So in this case, we have a 3x squared plus 2 over x squared plus 4x minus 5. So 3x squared over x squared. We're looking at those leading terms. And so as x gets really big, the other parts really become less meaningful. And it's the 3x squared over x squared, and the x squareds would cancel, so it's 3 over 1, leading coefficient over leading coefficient. And that's why this asymptote here is at y equals 3. We still have these vertical asymptotes, as we talked about before. But those are the three cases. So here it is summarized. Horizontal asymptotes of rational functions. The horizontal asymptote of a rational function can be determined by looking at the degrees of the numerator and denominator. The degree of the numerator is less than the degree of the denominator. The horizontal asymptote is y equals 0. The degree of the numerator is greater than the degree of the denominator by 1. You would get a slant asymptote. By the way, it's beyond the scope of this class, but if it's a degree of 2, you'd actually have a parabolic type shaped asymptote. And if it was by 3, you'd have a cubic shaped asymptote, where your middle stuff would do something different, but your local stuff is different, but your end behavior is going to look like one of those polynomial power functions. Degree of the numerator is equal to the degree of the denominator. The horizontal asymptote at the ratio, or is the ratio of leading coefficients. Yeah, I don't know where the at came from, but whatever. So for the functions below, identify the horizontal or slant asymptote. So this first one, they're the same degree. So your asymptote is just y equals 6 over 2, which is 3. In the second case, it is 1 degree more on top than bottom. So I'm going to take this, I'm going to do division here. So let me come over here and say, okay, that's negative 2 in the box. I have 1, a minus 4, and a 1. So 1, that's negative 2, negative 6, positive 12 is 13. The remainder doesn't matter. It's just this part. So this is your x, this is your constant. So it's going to be y equals x minus 6. That'll be your slant asymptote. And then this next one, x squared plus 4x over x cubed minus 8. So the degree is more on bottom than on top. So it's just y equals 0. Okay. Example 8, in the sugar concentration problem, we created the equation C of t equals 5 plus t over 100 plus 10t. Find the horizontal asymptote and interpret it in context of the problem. So we'd be looking at, so leading coefficient's 1 here, it's 10 here. So our asymptote would be y equals 1 over 10. And that means your long-term concentration would be 1/10. Eventually, as t gets really big, C of t would go towards 1/10. So that's where it would eventually end up. Okay, find the horizontal and vertical asymptotes of the function. Let's see. Nothing's going to cancel here. X minus 2 times x plus 3 over x minus 1 times x plus 2 times x minus 5. So the degree is more on bottom than on top. So the horizontal asymptote is y equals 0, but your vertical asymptotes are going to be at x equals, we got x minus 1 equals 0, so x equals 1. X plus 2 equals 0, so x equals negative 2. And then x minus 5 equals 0, so x equals 5. So those would be vertical asymptotes. Okay, and that's it for this video. Next one's intercepts of rational functions.